Hey buddy, did you ever wondered how your Java code decides yes or no? In this video, we will have a look on Boolean data types, which is maybe the tiniest, not maybe, it is the tiniest data type behind every decision of your program. By the end of this video, you will read, write, reason with Boolean values like a pro. The Boolean stores one of two values, which is either false or true, and that's it. Think of on and off, yes or no. The idea comes from mathematician George Boole, and his logic underpins the modern computing today. So I already prepared an example here. Maybe define another Boolean value, which we call is a second Boolean value, and we assign to that variable the value false. And let's print that out and say is Boolean value maybe a second time, and this time we want to print the second Boolean value. And if we execute that, you will see the output below here. But that's not the meaning of this video. So let's go to the next example. The Booleans which I typed here are basically manually typed, but most Booleans you will use are not typed at all manually. They will come from expression that evaluate true or false. So let's do another example and say this time we want to initialize a value integer 10 and maybe another one, call it epsilon equals to 9. And if I want to print that out line, we can compare these both values with the logic operators. So as an example, let's say x is greater than epsilon. And if we execute that, you will see that the value is true because x is obviously greater than 9, right? We can turn that table around and say not greater but less. And if we execute that, you will get false because it is not greater, less than epsilon, right? So we could also say, without saying or assigning or comparing variables with each other, we can directly say 9 and 10 inside the comparison, and you will get the Boolean value again. So 9 is less than 10, right? That's why we get the value true here. So we can go ahead and say maybe x is 10, but this time we want to compare x is equal to 10, or we can also say x, or instead x, let's say 10 or 15 equal. And if we print that out, in the first case, we will get a true, and in the second place, we will get a false. So take care of that. You're basically not assigning another value to 15, you are comparing. So that's why we have to use the double equal sign here. There are also other comparison operators like greater, equal, or less than equal. You can also use not equal to 10. And if we execute that, you will get the same value for the first comparison, but not the same in the second place because 15 is not 10, right? Maybe now let's do a real life example. And all we want to do is whether to decide a person is voting a label. So let's say an integer value and call it's my age as a variable name and 25. Second value, call it voting age is 18 because people can only vote either when they are 18 and above, right? If we want to system print out line and we compare my age is more or equal voting age, and if we execute that, the value is voila, true because I'm 25 and the voting age is 18, and we are comparing whether the my age, which is 25, is greater equal than 18, right? But that's not how you implement logic in your program. Programs usually create value or logic when you use if-else statements. So let's do that. We will cover if-else more in detail in other videos or in future videos, but in the focus of this video, we will use a simple if-else statement. So let's get rid of this system out print line and say if parentheses, and inside parentheses, we want to check a condition to execute our programs on it then. So our condition, as we said before, is to check the age of a person, whether it's voting able or not. So if we say my age, as before, is equal greater than the voting age, then curly brackets, So basically, when this is matching, then execute that code inside the brackets. And we say system.getLine and say old enough vote. If we execute that, you see that we are old enough since this condition is matching and the code here is being executed. But what happens when we are below 18? Let's execute. Nothing. For this case, you can also say if this code does not match, then execute else code. So the opposite of this condition, basically. And in that case, let's copy that here inside and call not old enough to vote. And let's execute that. Voila, I'm 17 and the voting age is 18, which is being checked here. Since this condition does not match, this code is not being executed, but else this code is being executed. So I guess that's enough about Booleans until now. In the future videos, we will dive deeper into logic implementations or make use of Boolean data types. So we will see Booleans all the time. Some examples is like when you're using a Boolean value to, for example, validate a user input, like to use it also as a future toggle or basically on and off. You can also use a Boolean value inside loop conditions, like if a condition matches, then execute that Boolean loop. So all of these boil down to our true or false values via code checks. And I hope you liked this video. If yes, then leave a like and also subscribe. That would make me very happy. Thank you. Stay healthy and goodbye. Or make use of Boolean data types. So we will see Booleans all the time. Some examples is like when you're using a Boolean value to, for example, validate a user input, like to use it also as a future toggle or basically on and off. You can also use a Boolean value inside loop conditions, like if a condition matches, then execute that Boolean loop. So all of these boil down to our true or false values via code checks. And I hope you liked this video. If yes, then leave a like and also subscribe. That would make me very happy. Thank you. Stay healthy and goodbye.